I would like to ask a brief question.
Yeah, please do.
Okay.
Absolutely. Sort that out for us,
So,
yeah.
so, so the so let's suppose that I have surveyors, and they set up monuments that are 100 miles apart. Okay. And then
Sure.
they go out with theodolites and they set them out in an equilateral triangle. Okay. Well, they set them out and they measure 100 miles on each side between the three. And then they go out with theodolites and they measure the angle from at each monument to the other two monuments. Okay, so we've got three angles. What will the
A
angles add up to?
triangle, yeah? Triangle,
Yeah.
that's 60, 60, 60, that's 180, yeah?
Okay. Would
Good
you be
question, Spurs.
surprised to
Good
learn?
question.
But you
Well,
do realize you can't,
that was a good
you
answer,
can't have
but
sir, you can't have a
but
triangle on a sphere though, sir. You do realize that.
that's exactly right.
That
So
add up
would you
to
be can
180,
can
yes.
I yeah, which is exactly right. So when people do this in practice, they don't get 180 degrees.
Okay.
They always
So
get
that
more than
means,
Hey,
180 degrees, which
so
is
that's
Craig,
not
what
a
you
I'm
would
sending
expect
you
on a
that.
spheroidal Earth. Yes, that's not a triangle, but it is 3
Craig,
points on Earth's surface. It's a spherical triangle.
What are you trying to say, team?
oh no,
yeah,
it's
so
alright.
that's
I was gonna
questionable.
let him
What
finish.
what you should do, Craig? My good
Check
friend
Discord.
Bev, try thinking. Is an expert in this field here when it comes to triangles.
I'm
What,
sorry. Yeah, Jinx, fight the flat Earth. You owe me a Coke now. Can't talk until you pay me.
You just said
Craig?
is wrong.
Look, if Sir here wants to
Oh,
speak about
fucking hell.
triangles, three angles that add up to the 180 there. So he's gonna have to bring on Bev. He's the expert. He's the professional. He will be able to demonstrate
Spurs,
exactly. But
Bev, I
what I
asked
would like
Bev's
to do
been
Bev
with
run,
to
team
come
Bev's
on
been
here.
and
running
speak
from
with me
me,
about
Spurs.
geometry. Hold on,
Can I
we've
give
been trying
Bev
to
the
get
link?
Bev to come on and speak
Hang on,
about geometry.
Craig.
Yeah, but we've been trying to get him to come
Craig.
on and speak about geometry for a few weeks now, and he said he would, but he won't do it. He just will not come on. I don't
Yeah, come
understand.
on.
How did we scare you,
If
Bev?
it's
We were actually pretty polite last time. Why are you so scared to come on and talk about science and math, man? Come on, don't be scared. Sorry, Spurs. You brought him up, not me.
I mean,
yeah, I mean, I think
So
yeah,
go on,
he's willing to
Tony.
come on. I think.
okay, well, please, but do you see that that's a problem? That every time that is done in practice, you get an answer of more than 180 degrees. Do you see that that's a problem for the flat Earth?
And I can prove that. I can absolutely prove that right now if you give me a second.
Oh, hey, I've
See,
got I've
this
got
is
some documents to show too. For a long distance land survey done in 1977, before the flat Earth topic was one of where all science is trying to hide the shape of the Earth. No, I have actual data that shows that land surveyors, independent of this argument, came to a conclusion that would support that the Earth is
Yeah,
shaped like Earth.
me
And
too. I'm
it's
just getting some up.
absolutely with measuring the zeniths between theodolites at at known distances, known elevations.
Yep.
So is it
Prior to
okay to send Bev a
GPS,
link?
prior to
I can
anything.
send him a link. Is that
I'm
okay?
sorry?
Because I'm going to get off to you anyway. And
If you want
I just
if
want
you
to
want
wrap up
Bev to
this.
come on and argue, then yeah, sure. I'll give you a link.
I
Well,
just need to step away from my computer for a moment.
okay.
Yeah, I've got
I mean,
things
I'll
I've got
send the
to do
link
too before it
if
gets
he
too
comes in.
late. So I'm probably gonna have to get off myself.
Well, Bev
Yeah,
can
it's really
certainly
late
argue
here.
with Tony. Let me just get a link for him. If Bev
Yeah, I mean
Bev
Tony
comes
Tony can
on,
handle Bev.
Bev comes
Bev, the
on
challenge still
yeah.
is
Only
yeah,
if
Bev.
he agrees to debate Team about geometry on Team's channel.
And we don't have to leave it at just geometry. We can debate on geometry specific to the shape of the Earth. I'll leave it at just that.
Spurs, tell Bev he's got a link in his Twitter inbox.
And if you
Okay,
want to get
I
brave, we
think
can talk about the geometry of space-time.
he's
Oh
listening.
goodness
So I
me!
think He'll get that. So look, can we just get these images up then, because we can wrap this up then, and we can explain.
right.
I
Yeah.
sent it to Craig. I
Yeah,
sent it to Craig.
One sec. Yeah, that one.
Yeah, I've got about 5 to 10 more minutes, Craig, before I have to get off. I've got to be somewhere before 9 p.m. tonight, and it's right down the street, but it's getting real close to that time.
Is your pimp putting you to work?
No. I have off Friday nights.
You have off Friday nights.
I'm sorry. You're expecting people to pay money?
I know. This is the problem. Team is.
Have you
not a
seen
very
this
good
fucking
prostitute.
face, guys? Spurs. You've seen my face before, yeah? You've seen my face
I've
before, yeah?
Yeah.
Yeah.
Okay.
we've
Whether
seen it.
I'm
It's
your cup
terrifying.
of tea or not, people would pay, wouldn't they? Don't lie.
For it to go away. Yeah, definitely. And guys,
No, shut up, fight.
Team,
We're talking to the intellectual here.
One sec. To my new subscribers
Please,
that have come over from Simon Dan, this is the face we're talking about.
Well, I judge by the character. I'm sure when Team realises the Earth
Exactly.
is not a globe, he'll be fighting the globe just as much as we are. So
Team's never.
we'll see you on the other side there, Team, shortly.
That doesn't answer the question about my street value. So, good people pay, not necessarily you, but people in general. When they see that face right there, they would pay, wouldn't they? They'd drop some dollars on that face.
For it to go away.
Make it rain on me.
Definitely. That's the
I
face
love
you
you
would pay
too,
for.
Spurs.
Yeah.
Thank you very much.
Absolutely.
Exactly.
Right.
You pay for that shit.
Spreading the
Looking's
love.
free,
Spreading
but
the love.
touching's gonna cost you.
Right, here we go.
In all-
This is what you're asking for.
Fantastico. Okay, so, sir, we've got
Yep.
a physical obstruction with the pipes and the plasticine. Yes, physical obstruction,
Yeah.
and we're causing refractions for the object to refract over that. We could say, would you describe that as a horizon? What would you describe that point where the pipe and the air, the atmosphere meets?
Let's call that a horizon, sure.
Let's call that a horizon. So that point, sir, from the observer will never ever change. We could measure that. That will stay there. It's physical. Same as the picture on the far left. That should stay there
No.
because it's a.
No.
Well, let me just clarify how I understand it. So, the picture on the right, far right, picture on the far left is causing a physical obstruction. Physical, not an atmospheric one. We can't see the bottom because it's been obstructed. Now, refraction will bring the object over the object on the right and should do with the object on the left. But what we find is that if he were to pour the liquid on the object on the right, the horizon would move behind the object and the object wouldn't refract over the horizon. We've got this in reverse, sir. How do we explain that?
So, look, I can only tell you that what you just said makes no sense.
So what we've got, sir, is
and-
reverse. We've got horizon
No,
refraction.
you don't understand. It's not the case that I don't understand what you're saying. It is the case that what you are saying doesn't make any sense. And you
Okay, what does the
repeating it
picture on the right
isn't going to
illustrate, sir?
make it make sense.
What is the point of the
Um,
image on the right, sir? Why are you demonstrating the image on the far right? What's the purpose of that, sir?
The purpose of the image.
On the
purpose
right,
of the
sir. What are you,
video was
what are you
to
demonstrating on the
to
far
show
right,
that things
sir?
can be refracted around the horizon.
Yeah, so that was the purpose of that video, is to show that light can, in appropriate circumstances, refract around obstructions.
So
Physical
you're showing
obstruction.
that object can refract around a physical obstruction.
The light from an object can refract around a physical obstruction.
Okay. So that physical obstruction did not move, sir. The pipe, sir,
Yes.
didn't move. So why did
Yep.
the physical obstruction in the real world on the far left, why did that move, sir? If it's physical like the
It
pipe.
didn't. It didn't.
It didn't move, sir.
It,
So what happened, sir? Why is it behind the platforms?
Because the light got refracted.
um, so you seem to be having a lot of at this stage. I have presented the explanation several times, and we are simply failing to communicate. Which is
Sir, I'm trying
why
to say this extremely slowly. The pipe is physical. The measurement from me to the pipe will never change, sir. From me to the
Yes, that's
horizon
right.
of the pipe will never change. Never ever
Yep.
change.
Yep.
Okay? But the object, sir, the distance, the appeared distance can change. It can look like it's closer or further, sir, because of refraction. Yes?
Yes. Yep.
So, the picture on the far left, sir, the horizon, the physical horizon has moved, sir, not the object, sir. We're looking at two different things, sir. We've got the object on the right moving, but the horizon on the left moving, sir. How is this happening?
Can I show you a video that someone has sent me quickly, Spurs?
Well, I'd rather an answer from sir of how we have two opposing images and observations. One is the object over the horizon, one is the horizon behind the object, sir. How do we get the pipe
So
behind the object?
so you are not moving the pipe. So what you and it is the most what you are observing is refraction of a different character.
What kind of refraction, sir,
so
is that?
well, it's so in the example in the video, what you're observing is a very narrow, discontinuous set of atmospheric conditions that only show a strip of what's over the horizon. Whereas in the atmospheric case, there's a continuum of refraction that makes the object, that makes the vista appear continuous over the. So that there's minutely different refraction paths for each of the light beams from along that line from you to the apparent horizon. Now, there is nothing in those images that suggest that the obstruction has moved, and you can assert otherwise as much as
I'm
you
not
want.
asserting, sir. I'm asking you. We see the bottom of the platform, sir. How is that possible? You didn't
Because
go
of
higher.
refraction.
Okay, can I interrupt real quick?
Shoot.
Just real quick.
Sure.
But the object,
so,
the object
uh,
didn't.
Yeah.
The
Well,
object didn't.
here,
The
Spurs,
object
one
didn't
second.
move, Craig. You say refraction, but the
Okay,
object,
but
just like
Spurs,
the plasticine,
Spurs,
did not move.
No, the apparent position of it.
Spurs. Let
Go on, team.
me explain something real quick. Will you put the image that I sent you up real quick?
Where did you send it?
Okay, now in this image, no, I sent it to
Where-
Fight.
where-
He knows what I'm talking about. It's the image,
Oh.
the screenshot you told me. The screenshot you told me to take. Okay, so let's
Yeah.
imagine from the top from the top of the cylinder. Do you see where the red stops? See, the red is continuous. Because of how this experiment is set up, it's not a gradual changing of temperature and pressure and density going up away from the top of the cylinder. It is when there's nothing poured on it, but once something is poured on it, it changes the density right there. So it's kind of a little bit misleading because the red doesn't go all the way up. You don't see the full can. If the entire atmosphere above the cylinder was, the same, analogous to to what is right on top of the cylinder, then you would see the whole can behind it. But that's not the point I want to bring up. The point I want to bring up is that if you were to take this image right now and put a point at the top of the red, okay, and you were to take a string from that point on the can to the cylinder, all right, we'll just say that string right now under these conditions would be visible. Now, when the conditions are normal, that white string would not be visible. So
Sure.
it is lifting not just the one object behind it, but it's lifting all the light that's coming from anything, even the light from between the canister and the can and the canister. Even the light between that is being refracted, but there's just nothing to see there. So if you were to take a white string or a white plane or anything that you want and were to line it up in this orientation right here, then when you remove the refractive index, you would not see that line anymore. You wouldn't see the plane. You wouldn't see anything there because then it would go back to being blocked by the cylinder.
Okay, that's fair enough. Again, this is not being disputed. You're bringing the
Okay.
plasticine
So-
back over that curved pipe, right? You're bringing it back.
Yeah, but it's
with
also
the
if we had something physical, but if we had something physical that ran from the cylinder to the canister behind it, it would be bringing all of that over to C.
Again, I'm not disputing that because that pipe will never
Well,
ever
that's what
change.
we're seeing.
No,
But
what
if
we're
you go
seeing
to
in
the
the Black
other
Swan,
pictures
what
that
we're
you were
seeing in
showing,
Black
the one that
Swan
had the one that had the high refraction. Okay, go ahead. I'm sorry.
But what we're seeing in the Black Swan, is the horizon moving, not the object. The object stays in the same place, but the horizon has moved behind it, not the object. You keep on talking about the object. The object stays
Right.
where it is.
Right. So when I said that if we drew a white line from there to the thing, then that would literally be like an extending apparent horizon.
No. You
Because
can't
when it's
draw,
gone,
you can't
the
draw
apparent
a line.
horizon comes back to the
Yes, but
cylinder.
hold on, T. You can't draw a line to the red because it's not in line of sight in reality, is it? It's refracted.
No. What I'm saying is, let's say we stop this picture right here, right? And we picked a point on that canister that's in the red, all right? Now, I'm not saying draw a line, a physical line from here to that point that we're seeing. I'm saying draw it to the point on the canister. So really, it wouldn't be going straight up like it is with the line of sight of the camera. It would really go kind of down. The only reason it looks like it's up is because it's being refracted over the canister. It would only look like it's pointing up. The actual physicalness of the line would still be pointed down, relative to the way the camera's pointing. It would be pointing down to the canister. Something that would represent a light ray that could make it that an observer would see if he lifted his camera up, but would be blocked by the cylinder when it's lower.
Again, this is not the argument, team. You're arguing for something else.
No, it is. You guys strawman the argument. This is what we say.
We're not
So-
disputing that this happens. This is what should happen on a globe. You have a physical
And it
horizon
does.
like this. No, this is what should happen. You should have a physical horizon like this that never ever changes its location. So if I
No,
come back
but the
tomorrow,
apparent position
that
of it
horizon
changes.
from my distance should be the same.
No, because
So-
the horizon can be refracted as long as there's everything else. Let me just quickly show you a video.
The horizon, where's the horizon in this image that you've got up?
The geometric horizon can be calculated quite easy. But watch this video, all right? All right, the physical horizon doesn't move position, but you induce some refraction, and all of a sudden the horizon is behind those platforms. That's exactly what refraction does.
Where's the horizon here?
Well, it showed you where the horizon was when he takes that away.
It's the line where the water meets the sky.
So you can see the horizon
That
here. Clearly,
there.
clear-
What?
look,
hold on
Spurs,
a second
Spurs,
there.
hold on. Look,
Ray.
that's the
not
horizon right
correct.
now, yeah?
No,
That's
that's not correct.
What is that then?
You've
What's that
just
line
shown
there?
you've just shown me a geometric hard horizon without atmosphere. That's not what happens in reality.
No, there's still atmosphere there. But what we're
There's
doing,
There
Still
isn't.
atmosphere.
but what we're
No, there
doing,
isn't.
Yeah, there is.
yeah, right. But what the point of then inducing the refraction is to show you that refraction can
That
change
is
the
still
apparent
a
position.
geometric. No, but that is still the geometric physical horizon.
But the apparent position of it has changed. The apparent position of the horizon has gone from being in front of those platforms to being behind those platforms.
No, we don't
purely
see
because
the
of
geometric
refraction.
physical. No, because we don't see the geometric physical
that there,
horizon.
then?
We see the apparent horizon
What's this here?
outside. That is a geometric edge.
A horizon.
That would be an edge, yeah, a point you can mark that will
A
never ever
horizon.
change.
You don't have to be afraid of saying the word. That's a horizon.
But it's a point we can measure, and that would never change. So from that point onwards, the
Yes.
Absolutely.
from that
Absolutely.
point on,
But
from that point on, from that
optically,
point onwards,
wait,
the curves
Spurs,
start
Spurs.
to drop away. That's what
And
you forget. You see,
And it does. That's what would happen after this horizon. The Earth would drop away. However,
no. So the picture on the left, from that
Wait,
horizon,
Spurs,
Earth will
wait.
start to fall away.
purely by refraction, the horizon is now behind those platforms. The physical position of the horizon has not changed, but the apparent position of it has because of refraction.
Yes, and I said, when you see the horizon, things are dropping behind it. So that means the Earth is falling away. That can never change. That would be the same every single day.
Yeah, but the apparent position
So
of
can
what's
I
falling away
ask-
can change.
Not what you
I'm
measure.
going to come at this with I'm going to come at this from two different
Well, it's going to be the last point,
perspectives.
'cause I'm going to have to go now. So.
Okay.
And Bev has come in.
Okay, so
So Bev can talk to the PhD in a second.
2 points. One,
PhD in a second.
2 points. One, are you one of the top 30 intellectuals on the face of the planet?
So it's not about me, sir. It really isn't. I don't
No,
profess to
are
be
you?
wise.
Are you? Okay, so there are people who are more intelligent than you out there. I suggest you
Sure.
find one and get them to explain this to you. Now,
I'm speaking to one right now,
have
sir.
so I have a PhD. I have also represented my country multiple occasions in mine sports. So when we get to a situation where you're saying you don't understand something and I'm saying you don't understand something, I am going to conclude on the basis of the evidence available to me that actually you're the person whose understanding is uncertain. And I'm going to try and help you out as best I can. But you seem to have this refusal to accept, because you haven't changed your positions. We've been discussing this for the better part of an hour, and you just haven't changed at all. You have not accepted. And this may be, I don't know how to explain it.
No, it's
but
not
you're
you.
going to have to
Cool.
find somebody you trust, whose authority, whose intellectual authority you respect, on a genuine level, and talk to them about it.
But he's gonna
Because
choose another photographer.
please believe me, you are wrong, and I don't know how to say it gently.
That's absolutely fine. So I appreciate the time that you've spent, and hopefully we can do this again some other time. Craig, Team Skeptic, it's been a pleasure. Go ahead,
I
sorry,
would like
sir.
to
Yeah,
say
same
that
Spurs.
I
Hey, man,
I would like, please, you can call me Tony. Honestly, it feels very unnatural for you to call me sir.
He's doing
Just
it
call me Tony.
facetiously.
Yeah, well, again, I'd prefer he not do it if it's facetious. But the other point is that you've been very civil, and thank you for the discussion.
Thank you very much. Thank you very much, Tony, as you preferred to
Hey,
before. So, guys, I will catch you all later on. We'll do this again, Team.
Bye,
Craig.
Spurs.
Don't be scared
Have
to
a
come
good
hang out
evening.
on my channel, Spurs.
Will do. Have a good evening.
Yeah, well done, Spurs. Good job.
Oh wow.
Bev!
Bev.
Why are you running me, Bev? We're supposed to have a conversation fucking weeks ago, man. Come on, what's wrong?
What are you doing? What are you talking about?
We started talking about geometry, and then you said something about coming on and discussing geometry on my
No,
channel.
you might have said
So-
something about that.
You said you'd be up for it.
Yeah, you said you'd be up for it. Remember, you don't remember having
I
this
said
conversation
I
with
said
us?
I'd come on if you demonetized, didn't I?
Aye, but why would you ask him to do that when this is his
Well,
job?
that was after.
I mean, is
no,
he-
that
is
was
he gonna
after
do that?
we fucking.
No,
You gonna do
why-
that?
Hold on.
No, why would
That
you?
was
Okay, fair
after.
enough.
That was. Hold on. That was after you agreed. You then told Craig in an email
I
that
didn't
you would come
agree
on. Why
to
are you so
anything.
scared to?
Like, you-
Hold on,
delusional.
but I'm nobody. I don't have a college degree. I'm nobody. Why would you?
I'm nobody
feel
either.
more comfortable
Oh, we know.
discussing. I know we're both nobody, so come on, man. Quit trying to act like you're better than me. Let's go.
I'm not trying to act like I'm better than you. Anyway, Tony,
I'm just
you were
fucking with
talking
you,
about
Bev. I'm pushing
triangles
buttons,
earlier
man. Come on.
with your
I
surveying.
was talking about Yes, I was talking about. Well, I was talking about spherical triangles.
Guys, I gotta
talking
run.
about.
Yeah,
Hey,
see you
hold
later,
on.
team. Thanks for coming.
Tony, I legitimately have to leave. So, guys, y'all have a great night. Bev, I'll be looking forward
You too.
to debating you and crushing you, man. So whenever you're
And
ready, let me
anytime
know.
you demonetize, I'll
He's
be
not going to
ready.
do that.
Hey,
Oh, well,
I don't
take
want to
care,
hear that
Tim.
shit because Craig has it. Craig has his shit monetized right now, and you're here. So you're making excuses now. Either keep making excuses and run, or man the fuck up. I'll talk to you guys
You
later.
can come over to Emma UK anytime.
Yeah, but we can also stream it on our side.
Yeah, you can. Of course you can.
Team, thanks for coming on, dude. Right, Bev, this is Tony. Tony has a PhD. Literally works with gravity and stuff. So he was talking about triangles being greater than 180. Would you like to question him about that?
Yeah. Sighted triangles from point to point with a theodolite.
Yep. On length scales, large enough. Yes.
Length scales.
Length
Straight
scales.
line from
So
point to
if
point.
you, so if I, yes, straight line, point to point.
Measuring angles.
Yes, you're measuring. So you let's say you've got points A, B, and C on a surface, widely separated, and you go to point A and you measure the angle. You measure the angle between B and C. Then you
Yeah.
go to B, you measure the angle between C and A, etc., etc. When you do that and you add up the observed angles, you get more than 180 degrees. And
How do you work that?
Because, like he's just said, you measured them.
because you're measuring the angles and then you add them up.
Okay. And angles like from point to point, that means two straight lines, right?
Yes.
And three angles would be a triangle with straight sides.
Okay. Yep. And if there are two cases. Either we are on a flat surface, in which case it's a simple flat two-dimensional triangle that you are entirely familiar with, or Earth's surface is spheroidal, in which case we're talking about a spherical triangle that obeys spherical trigonometry.
Right, but we are measuring point to point.
Yes, we are measuring point to point.
Yeah. Well, that's straight lines then, right?
Well, I would be hesitant to. So you are pointing your theodolite directly from one monument to another monument, but the path that describes is actually curved because we live on a sphere. So when you say it's a straight line, you're asking, it's the most direct line you can trace on Earth's surface. Yes.
But you sighting it from point to point, right?
Yep, you're sighting it from point to point.
So you suggesting that the sighting line is a curved line?
I'm suggesting that the path between the two is curved. I'm not suggesting that, well, the sighting line needs to be corrected for refractive effects, which may occur.
But a triangle, like as you've just said, is three straight lines. Like, you do understand geometry, right?
Flat.
I would imagine the PhD guy does, yes.
I fail to see why I should dignify that condescending question with a response. I have already explained the distinction between flat Earth and spherical triangles in this discussion. Would you like me to explain it again using shorter words?
Well, if you'd like to, right?
Oh, you're so savage, I love it.
Okay, so if I have 3 points on the surface of a ball, right, and they form what's called a spherical triangle. The angles, the internal angles of a spherical triangle add up to more than 180 degrees.
And what I'm showing you on screen right now, Bev, is measurements demonstrating that. This is measurements of point to point, like Tony was explaining.
They look pretty old, them.
Yeah,
Do you know anybody that's actually done it that can confirm this, or
it's been done several times
Yes.
by multiple
Tony?
people.
Have you ever done this, Tony?
But Bev, you missed the point.
No, I'm not a surveyor, but I work with surveyors.
You see this column here that says spherical excess. That shows you how much each of these angles was over the 180, and every single one of the triangles were over 180 degrees. So
okay, they were sighted
Can
triangles, right?
yes,
Absolutely.
Yeah.
Sighted triangles. Can I just pick up on a point that Bev made?
Yeah.
These are old observations, okay? So this is from before the point where the scientific establishment was trying to preserve the fiction of a spherical Earth in your narrative.
You reckon?
Oh yeah.
When did this gigantic conspiracy? When did this gigantic conspiracy be initiated?
What conspiracy?
It's important. You said that's old. Well, there must
triangles
be a conspiracy of some
have 180 degrees internal angles, right?
Spherical triangles don't.
But you know what a triangle is, right? You know what an angle is?
Bev, do you know what a spherical triangle is?
Well, do you know what a triangle is? You'd have to start that first, right?
Yes, we know what a triangle is.
And three angles.
We know what a triangle is.
And do you know what a spherical triangle is?
Between two straight lines, right?
And do you know what a spherical triangle is?
I've got the definition here. Would that be all right for you?
Yeah,
give you a
spherical
definition.
Triangle.
No, he's just going to give us the definition of a triangle.
No, listen. A plane rectilinear angle is the inclination of two straight lines to one another, which meet together, but are not in the same straight line.
Yes, I'm a bit confused. So let me get this straight. So let me explain what I do for a living. One of the things I do for a living is on satellite orbits and how they respond to mass distributions on Earth's surface and inside Earth's interior. Now, you'd be surprised to know that that actually involves quite sophisticated mathematical and geometrical understanding. And so I'm going to suggest that perhaps you don't need to be telling me what a planar triangle is.
No, just an angle that was, wasn't it?
Yeah, but I asked you, do you know what a spherical triangle is?
Yeah, well, how you measure an angle is between two straight lines, right?
No. Bev, listen to the question. Do you know what a spherical triangle is?
Yes.
What is
but
it?
It's not got straight sides, has it?
Wow.
So you're abusing here the term straight.
Abusing straight.
Oh yeah, he does that a lot. Yes, this is his whole shtick.
So the so in multi-dimensional surfaces, straight corresponds to what's called a geodesic. It's the path of minimum distance joining two points on your curved surface. But that may not be straight in a different frame of reference.
Okay. Do you know to measure an angle?
So
right?
I'm sorry. We're going to move on from angles, and we're going to discuss
straight lines, right?
Dimensional geometry. Straight according to the surface that you're on.
Yeah, but you need two straight lines to measure an angle, because it is the bit in between, isn't it?
Surface, straight with respect to the surface that you are on. So if you're on a curved surface, the line will be curved.
We're just talking about a triangle. Like, that's a shape.
And
with 3 angles, and
yes,
that
it's
is
two-dimensional
straight
shape.
sides.
Yes. Because your surface, the surface that you're measuring on is flat. But straight, what is called straight line distance on Earth's surface are actually curved arcs.
Oh, so not straight lines then?
They are straight with respect to the Earth's curved surface. They are the lines of minimum distance. They are the geodesics.
Okay, but you're saying they're on a curved surface, so they would be curved lines, right? I've already been over this with Craig.
They wouldn't be. They wouldn't be. So you have sorry. What's your highest level of educational achievement?
Why is that relevant?
Because again, we're at the point where
We're just talking about
you're
angles,
trying
aren't we,
to-
on a triangle? It's not really that
where-
technical, is it?
Yes, it is, because it's fundamental to understanding how surveying works. So your refusal to understand how spherical trigonometry works is something
well,
of an
surveyors,
impediment.
see, this is where you're going. Like, surveyors use Euclidean geometry, don't they?
They
God.
can do, yes.
Stroke was...
Okay.
So would you be surprised? So you're a flat earther. What's your reference frame? Where
I'm
is
a
the
what?
origin of your reference
Sorry?
frame?
He's
You're a
going to
flat
argue
earther.
that he's not a flat
What did you
earther
call me?
because he's going to say that the Earth has hills
I
and
called you a
valleys.
flat earther.
Oh, yeah. Why did you do that?
Because, Bev, you are a flat earther.
Because you are. You're arguing that
why?
the Earth isn't spherical. What shape is it?
I'm arguing that level is horizontal, and
wrong.
triangles
Then you're
have
wrong.
180-degree internal angles.
Not on a sphere, they don't.
It's not a triangle, though, is it?
Yes, it is. It's called a spherical triangle.
That's not a triangle.
It's a spherical
It has
triangle.
3 angles. It's a
But an
triangle.
angle, you need 2 straight lines. Do you want
No,
me
you
to read
don't.
the definition again of an angle?
Well, I can use the limit of the angle between tangents. They're straight lines.
That's
sure.
2 straight
why not?
lines, yeah. Okay, so
Okay,
you're going to use
so there you go.
2 straight lines.
And what happens when you add in the third part of the triangle and you measure the internal angles and it comes to more than 180, Bev? What does that imply?
Where did you take the tangent in order to make your...
Answer the question. If you
At
measure
the
the
angle.
internal angles of the triangle and it comes to more
Craig,
than 180,
where did you put the tangent?
that's irrelevant. I am saying that if
No,
you
no,
measure...
it is
At
very
the-
relevant to measure your triangle angles.
Oh my God.
So I have 3 points on Earth's surface.
hmm
Okay, so I take line of sight at each point. I go to each point and I take
Yep.
a line of sight between that point and the other 2 points, and I measure the angle in between them.
Yep.
Now, the tangent from one point over short distances is going to coincide.
It's just
Nearly
a straight
exactly
line. Where you go with
with the-
tangent? Where's the tangent come from? You're just
well,
citing a point to another point.
Okay, no, or
Bev can't 3D.
so you have a propensity to ask idiotic questions that are completely irrelevant to the discussion at hand, and it's great for parties and pubs, but it just makes you look ridiculous.
Really?
So keep it up. I mean, if you're happy publicly humiliating yourself in front of however many viewers there are now, okay, fine. I mean, I can understand why you don't want other people to be paid for it, but it's.
When he said he's not a flat earther, I found out what he meant. Sorry.
Vince, apparently they prefer the word retard.
Eh? Oh, how very quaint.
Yeah, sorry, we
brilliant.
do get those two confused between retard and flat earth because they mean the same thing.
Yeah. So look, it's yes. Let's start with an experiment. Let's start with an experiment.
Let's start with the theodolite at point A, and let's cite a line to B.
Yep.
And then measure the angle from B to C.
Yep. And
then
they
let's
add
go
up
to
to
B.
more than 180 degrees again. Still.
Okay.
Always.
Brilliant. Okay. But you say you're not a surveyor.
Not personally, no.
Okay. Okay.
But I work with surveyors. I work with people with surveying expertise.
Any chance you could get any of them on here for a chat?
I've
got a really cool water level test.
Yeah, you do. It's fucking hilarious.
I have seen that water level test, and I have to say that I think you should seriously consider whether or not you're actually qualified to design meaningful experiments.
No, he's
A
not.
water level test.
Yeah.
Seriously.
Oh my god.
Yeah.
So damn it, I've deleted the picture.
So allow me to so a fluid of any sort adopts a geometry in response to the forces that are applied to it, right?
Fair enough. I think
Okay.
you're going to say normal.
So, I'm not going to say normal because you may have wind, you may have resistance forces from the container it's in, you may pour the water
Can we
out.
say
and it'll,
perpendicular then?
No, we're not going to say perpendicular. We're going to say that liquids adopt a geometry in response to the forces applied to them.
Equilibrium.
Because forces... I'm not sure... yes. What? Sorry. You just threw in a random word there. What do you mean by equilibrium? What are you trying to clarify?
When you put water in a tube, the two ends will reach a level or an equilibrium, right?
Yeah.
Yeah. Well, that's what a water level is, right?
Okay, so define level.
Horizontal.
Wrong.
No, I reject that characterization.
Do you?
Yeah, he's got to be right too because it is very wrong.
Level is a straight line on a
so-
horizontal plane. How's that?
That's wrong too. Well, sorry, you can assert that. But water won't obey that.
Well, a water level is a tool for establishing a horizontal plane of reference, right?
Over short time, over short distances, and with a non-zero error.
Okay, right. Oh, so what sort of a short distance would you say? What's the maximum length you can put on a water level, in your opinion?
Well, that
Here's
that
Bev's water
depends.
level.
Yeah, that's right.
That's
So,
one of the models, right?
South is down, is it?
Yeah, apparently.
Gravity
so.
just acts towards the bottom of the page, and that
Oh my god.
it is you seem to have difficulty. So imagine I've got a tube that as drawn here, it goes down, it goes across, and it goes up. Okay, so a difference in air pressure between two places on Earth's surface will result in a difference in the height in the tubes. Right?
Well, it's meant. Well, no, it
Yes.
establishes a horizontal plane of reference. The two ends will find an
No,
equilibrium, right?
but not necessarily the same height, because there could be different air pressure at both heights.
No,
At
you
both ends,
leave
right?
the tubes open, right?
Yes, and there will be, the air pressure varies as a function of position. You are aware of that.
Okay. So how far apart do you reckon would be the maximum distance you would say for a water level to maintain a horizontal frame of reference?
To maintain a horizontal frame of reference, to what precision?
Well, I don't know, as a scientist.
To what precision? Well, I think
to the precision to be able to measure curvature, presupposed curvature.
To the precision I'd suggest you'd need 20 kilometers.
20 kilometers to what? To notice any deviation from horizontal.
Before you get effects that are, before you'd be able to detect the difference between the two hypotheses, and you'd have to correct for a variety of effects. You'd have to correct for differential thermal expansion.
Two hypotheses.
You'd have to.
Mm-hmm.
Yes, we have two hypotheses. One hypothesis is that the Earth is a sphere, and the other hypothesis is that the Earth is flat, or largely flat.
But 20
so
kilometers, there's a fair bit of difference, right? Like, isn't there meant to be a difference over 1 mile? Or, like, half a mile? Quarter of a mile, I've heard people say that they can measure it. Some of the surveyors, I mean, I don't know if any of your friends have mentioned anything like that. But, I mean, I've heard surveyors say that they can measure it in quarter of a mile.
They're doing something very different than water level.
Well, one's a horizontal plane and the other one's got a curvature to it. So over 20 kilometers, I would imagine that's a fair bit of curvature on one model. And the straight line that horizontal would give wouldn't have any curvature to it at all. So why do you think it would take 20 kilometers for you to be able to tell a difference? Surely there should be a difference over 1 mile, right?
So, not necessarily instrumentally detectable. Using a water level experiment.
Using a water level experiment isn't any good over a mile.
There are Okay, so wind effects.
You realise how drainage works, right? Water flows downhill, right?
I'm going to ask you.
Like, what about a canal?
Mean surface conditions on a. So you asked me the question. I gave you an answer. You ask other people a question, they'll give you a different answer.
Yeah.
You need to do the experiment. If you want to convince me, you're going to need to do the experiment over the conditions that I say.
Over 20
Not
kilometers.
over what other people say. Yes.
Okay.
And if you can't do it, then
you can't. You seriously think you can't tell over a distance of 20 kilometers whether it's straight or curved?
I'm saying you can very easily
over 20 kilometers.
Sort of
oh right.
Yes.
Well, so why are you saying that you think I should have to go 20 kilometers?
Because what you're
in fact, there is a canal here down the road that leads to Liverpool Canal. Goes 27 miles between locks.
Yep.
Yeah. Well, is that not level?
So there you go.
Of course it is. Water is always level.
Of course it is. But that doesn't.
So that
make
curves, does it, or is it horizontal?
Yes.
It curves as level.
It curves.
Yeah.
Okay. So we should be able to measure then with a level.
Not with a water
like a
level.
Theodolite level.
Not with a level.
Is that horizontal?
No. With a theodolite, yes, but not with the water level thing that you are suggesting.
So right, okay. So you think a water level
will work.
Level, but a level is level.
like Tony was saying, you have to take a lot of things into account for the water level, like atmospheric changes, minute disturbances, plus meniscus of the water and everything. It's going to be very hard to see. Let's say 27 miles. Did you say it was? Yeah.
Yeah, in between locks.
All right. So that's about a third. So about a third of a degree.
Oh, it's
is what
about
you expect.
15 miles as the crow flies.
So over that 27 miles, you should expect to see a third of a degree deviation.
How many feet in drop do you reckon?
Drop from where?
Well, drop from the horizontal, because that's what
Right. So
your man's just said here.
a drop
And
from
you as well.
a drop from the
No,
point
I never
where
said
the,
anything
no.
of the sort.
Yeah, you did one curves and one straight.
Yeah. So when you say
Right,
a
so the
drop,
straight
do you-
one
do you
goes
mean-
straight, and the
I
curved
don't
one must
talk
drop
about-
away
I
from the
don't
straight
talk
bit,
about-
right?
All right, 2
I'm,
secs. I'll give you the
I'm
exact
not
figures
going to
for
talk
that.
about drop.
Well, what's it doing in relation to the horizontal?
Well, first of all, it rises up to it from
diverging.
your eyesight.
Oh, okay, diverging. In any particular direction?
Away.
Away. Oh, like upwards? To the left?
Define up.
To the right?
Define up.
Like when you stood there, right? And you're looking out on the horizontal.
What's your eye height?
Up is like towards the sky.
Yeah, Bev. What's your eye height for
Okay.
this 27 miles?
What do you mean? Eye height. It's the water level in the canal.
Right. So are you saying you want to know the drop? So are you saying the drop from right at the surface?
Well, yeah. Where are you going to stand on
Well,
the canal to find the drop? Let's say we'll
Well,
stand at one end of it, right?
Yeah, but I
This
need
is
to know,
why this
I need
drop
to know
thing
how
is
far-
so
yeah.
idiotic, and it only reinforces the mental misconception he has about the nature of the Earth.
Yeah, that's why I'm
With-
It
trying to
only
get
re-
him to
it
understand.
only reinforces
And what's curved?
it only reinforces the misconception that south is down, or
Can
you know
you-
that
can
you
you
know,
Bev,
science
Bev,
a straight
Bev,
line
Bev,
and a
Bev,
curve,
Bev,
dude?
let me make it more simple for you.
that's
You're-
meaningless.
You're 6 foot,
What?
right? Let's say you're approximately 6 foot. So your eye height that you are looking out at is 6 foot.
No,
Right.
we're on the surface of the canal, Craig.
Okay, so
we're trying to find
so
out
your eye height
how
is
much
0.
difference there is from a horizontal to the water level
Yes,
that
but-
you say is different.
Yes, but how
I say
high
it's the
is
same
your,
thing.
How high is your viewing of how high above the surface?
We're
of the
on the
are you
water.
looking at?
We're
So
we're in a
0 feet.
canoe on the
Zero-
water.
0 feet is what you're saying, right?
Yeah.
Okay.
So the reason I object to this is because down changes direction as you move. Okay, and so what you're actually referring to is the distance between a tangent at the point of observation extended outwards and the surface of the Earth at a different point. But by calling that drop, what you're asserting is that the force of gravity, or downwards, acts in the same direction uniformly along that path, and it doesn't.
Perpendicular, right? Is it not? Is it not a force normal? Is it not?
Normal to what?
Well, I don't know. What do you think normal is? It's perpendicular, isn't it? I mean, that's just another word
So
for perpendicular.
perpendicular refers to two objects. Something
Yeah.
is perpendicular to something else.
Yeah, if one
So
of
we're
them's
talking
vertical,
about the force of gravity. We're
yeah,
talking about
if
the force of gravity.
is
What is it?
vertical, then the other one
Um,
is horizontal, right?
No.
No,
Yeah.
we told you this before, Bev. Horizontal is relative.
It's perpendicular to vertical, right?
Yeah, but it's also relative to position. Your horizontal right now is different to mine because we're separated by approximately 700 miles. So my vertical, exactly straight up, is very different to what yours is. But for both of us, they are still vertical.
That's what you think, mate.
No,
what
that's
you
that's
think.
absolutely been demonstrated to be fact.
So one of the reasons that I brought up education level is that one of the things that we're taught to do as undergraduates is be very precise in the way we phrase things and understand complicated physical models. And you're insisting that your flat Earth geometry will work in every circumstance.
What are you talking about?
So
It's Euclidean geometry, dude. It's not flat Earth geometry.
So Euclidean
All right,
geometry.
I'm here.
Yeah.
Can I ask a question? Because I actually, for my last video, I had to do a lot of this research, and I actually consulted with Jesse Kozlowski about some of these measurements. Bev, on a flat Earth, if you take two theodolites and you line them up and you align them visually with each other, then if the Earth is flat, then you should get a combination, a sum of zenith angles that will equal 180 degrees exactly every single time. If the Earth is concave, okay, meaning that it goes up like concave earthers, then when you measure these zenith angles, the sum of the zenith angles will be less than 180 degrees. If you measure it to be convex, then the sum of the zenith angles will be greater than 180 degrees. Now, I have measurements right here that were taken in 1977 that I can show right now that are independent geodesic surveyors from University of Texas, I believe it was. And they did a survey in 1977 before any of this was a topic of discussion. And every single one of their measurements showed a zenith angle above 180 degrees. Not only that, but as you took a distance between 2 points, okay, if you take a distance between 2 points and there's a certain zenith angle, and then you go further and take another one, the spherical Earth predicts that the zenith angle will be larger the further you get away. When you take a second theodolite, the further you get away. And sure enough, it shows that the sum of the zenith angles increases above 180 degrees and continues to increase as you move a theodolite the further away. This is all evidence to support that the Earth is not fucking flat and that it is in fact spherical, convex, not concave.
Dude, you know when you say zenith angles, can you just explain?
He doesn't understand zenith
I thought you understood fucking geometry, dude.
No, I'm
You
just
don't
asking
understand what a
you.
fucking
Can you?
zenith angle is?
Do you want me to explain again, or because there might be some people that are listening that might not know? I was just wondering if you would like to take the first approach for it.
Yeah, the zenith angle is the angle of the observation relative to directly overhead. So if you have a 90-degree zenith angle, then essentially you are looking horizontal to the surface of the Earth. Now, if the Earth is flat, when you combine these two angles with each other, it should always equal 180 degrees. However, anytime a professional surveyor goes out and makes these measurements, his angle will be consistently above 180 degrees. There is no explanation for that for any other geometrical shape other than a three-dimensional spherical object.
Okay, so you're saying that vertical and horizontal aren't always perpendicular?
No, what he's saying is that vertical. So
go on.
So this is what I was saying. When you say vertical,
Team was just talking for Jesse Kozlowski. Now, you
mean pointing? So you are very trying.
Yes, he is.
The vertical means in the opposite direction in which things fall. Now, since things fall in different direction. Yes, vertical means up. Right?
No.
Objects fall down.
No. It's just a line in a position. It doesn't mean up or down. It just means vertical. It's like horizontal doesn't mean left or right.
You know that like horizontal, plumb, and vertical, they're not Euclidean.
So when you say the perpendicular, yeah, that's Euclidean.
So so your you are essentially too ignorant to use the term Euclidean.
Yeah.
Oh, really?
Yeah.
Yes.
Very much so.
Oh.
Like, understandably.
I think you find it to be a very clever term to use in daily talk, but I don't think you completely understand why it's clever and what exactly it means, nor how to use it cleverly.
Or why I've got a book on my desk that says when straight line becomes curves, non-Euclidean geometry.
Well, if
Oh,
you
my
do
logical
you
world.
have
Will
a
you share my
definition
screen?
of
Will you share my screen,
perpendicular?
please?
Yeah, 2 seconds.
Will you share my screen, please?
There we go. You're live.
Perpendicular is another word
Okay,
for
so
orthogonal.
this right here-
It's where. Yep.
Go ahead,
Sorry.
Tony. I'll let you finish that before I start.
So perpendicular refers to orthogonal. It's when two vectors have an inner product of 0. So a vector
God,
in any one
don't try
surface.
to use that cleverly, Bev. Bev, don't try to use that cleverly in no conversation.
What do you mean try and use what cleverly? I can give you the Euclidean definition if you want.
Yes, but the Euclidean, the Euclidean definition only you are taking the idea that horizontal is always in the same orientation, and vertical is always in the same orientation, regardless of your position.
Yeah, they're perpendicular to each other, aren't they?
They're always perpendicular to one another, but what I consider to be vertical, you don't consider to be vertical.
Well, I don't understand what you mean. Hanging a plumb bob
No,
is
we
what
know
I
you
would
don't understand
consider
what
to be
we know.
vertical.
Okay,
What
so
would you
this is
consider
okay.
to be
Great.
vertical?
Hey, hold on, but you lead it. You're bringing me into the point I'm trying to make right here. You said I don't understand what you mean by one vertical for one person is not another vertical for another person. Are you sharing my screen now? Fight?
Yes, yeah, you're live.
Yep.
Okay, here are the measurements right here, okay? These are the measurements between two people. Now, you can go through and do this. I'll share all the links. This is from the actual person who made the measurements. He documents the whole thing, so you can go back and read. But the key is right here in this table. Now, if you look, this is the zenith angle. This is a measurement from 1 to 7 and from 7 to 1. Now, the zenith
Looks a
angle
bit
is
grainy,
91.0809.
Sorry, I'll up it to you.
Okay,
One
Fight,
sec.
can you?
Yeah.
Yeah.
There we go. It should get better now, Bev.
So what you'll notice is that when you add up these two zenith angles, and this is from the plumb, so that means your vertical is determined by something called a plumb, all right? So they use a plumb to align their theodolites, and then they visually align them, and then they measure how much off the plumb is that particular measurement. Okay, so if it's flat, for instance, let's say you have one person that's at a slightly higher elevation and another person that's at a slightly lower elevation. If it's plumb, then in a direct line of sight, if it's flat, then in a direct line of sight, those two angles, one will be greater than 90, one will be less than 90, and they will still add up to 180 degrees. That's just geometry, planar geometry. Now, on a circle, on a sphere, okay, the plumbs become offset. They're relative to one plumb, relative to line 1 or point 1,
offset.
0.7's plumb. I'm sorry?
What do they become offset to? Like, how do you measure your offset?
It's determined by the radius of the Earth and the distance that from point 1 to point 2. Point 2 will be off by
deviation
in ours,
of
it's
the
roughly
offset of
1 degree
of
per
vertical.
69 miles. It's roughly 1 degree
what I'm
per
saying is,
69 miles.
How
in the
how
Earth.
do you measure the offset of a vertical?
This is I'm showing you right now. I'm showing you right now.
What
so
do
when
you measure
line
it
up the two
from then?
theodolites,
This is
your
this
plumb.
is what we're.
Your plumb. So, okay, this is exactly what we're saying. If it's flat, no matter what the orientation is, they should always equal 180 degrees. If it's convex, no matter what the orientation is, they should always equal less than 180 degrees. Concave, I'm sorry. If it's convex, then no matter what the orientation is, they should still add up to 180 degrees. No, it's not. What do you mean fucking scripted?
Okay, so
I just understand what I'm fucking telling you. Then if you look at the sum of the zenith angles, 1 second, Tony. If you look at the sum of the zenith angles, every single one of them is over 180 degrees. And then at the same time, if you look over at the fucking distance that they measured them to, okay, you'll notice that the sum of the zenith angles increases with distance as well. This is evidence to support that the Earth is not flat and that it is spherical in nature and three-dimensional.
You're good at geometry,
Go ahead,
right?
Tony, I'm sorry.
Team, you're good at geometry.
So,
I'm better than you.
Bev. So
wait a minute. So if you have a perpendicular at the bottom of each of those lines, and you were to draw them perpendiculars out, they would intersect, right? I'm just
no.
Let Tony say what he's got to say, okay, and then you can respond. All right.
Okay. So Bev, if you drop a plumb bob from a string from your ceiling, and you draw a line through that, just a continuous line, okay? And I do the same thing here. I have a plumb bob hanging down from a string, and I draw a line straight through it. Your mental image is that those lines must be parallel, right?
Yeah, wait. What's up with that?
Okay. They're not.
Yeah.
Well, they'd both be perpendicular to a horizontal, right?
They're perpendicular to different horizontals.
Mm-hmm.
So horizontal's different then?
For each person,
Does horizontal diverge from the horizontal?
Horizontal is different at different locations on Earth's surface.
Oh, really?
Right? And that's what we're... Yes, really. Okay. Demonstrably, in fact.
Are you want to... Like, if you say then horizontal is horizontal on your model at the North Pole, would it be horizontal at the South Pole?
No. So
okay. So where would it be horizontal then?
So it's
just so we can get a frame of reference. Let's give us somewhere.
It's horizontal everywhere on the. It's horizontal everywhere.
Yeah, but in relation to being horizontal, you said it differs from horizontal, right?
So,
right.
At any point...
So, is the horizontal at the North Pole the same as the horizontal at the equator? Or could you call them two horizontals perpendicular to each other?
They're perpendicular to each other.
They'd be roughly perpendicular,
Yeah. So, horizontal is also perpendicular to horizontal.
The horizontal at one position, the horizontal at one position can be orthogonal to horizontal at another position. Yes. Okay. The two planes can be orthogonal,
whilst being perpendicular to vertical. So that means that every time you say horizontal is perpendicular to vertical, but you can also say vertical is perpendicular to vertical, and horizontal is perpendicular to horizontal. But that would also mean that horizontal is at 45 degrees to horizontal as well, right?
Yep.
Because all things go here with this now. So you don't really have a vertical and / horizontal frame of reference.
It's local. So vertical
and
horizontal are defined locally.
Okay. So if I make a perpendicular, and then walk along that perpendicular, can I drop another vertical onto it? And would that be perpendicular to the horizontal?
No.
Oh, is that so? That's a one and one only vertical being perpendicular to horizontal rule, is it?
No.
Oh. So you are allowed more perpendicular verticals to a horizontal?
At this point, you're spouting gibberish that is barely comprehensible.
Welcome to my world.
Well,
And
I'm like I know that
your-
vertical
this is
and
your
horizontal
problem.
are
This is-
perpendicular, right?
Bev, I want to ask you a question, okay? Do you understand what the difference between Euclidean and non-Euclidean is?
No, you don't.
One of them is Euclidean,
Okay,
and
simple.
it's
I'm
very
not
well
trying to be- I'm
defined
not trying to be an ass
geometry.
here.
The other one isn't that.
Okay, that was the incorrect answer.
Fuck me,
I'll
that
ask
was
again.
stupid.
Do you understand? Well, I mean, we interrupted him a little bit, so I'm going to let him get a chance to explain better. Can you tell me what the exact difference between Euclidean and non-Euclidean geometry is?
Euclidean geometry is a very well defined geometry system with axioms, definitions, and propositions. The other one isn't that.
My
You don't-
fucking god.
That's actually nonsense.
That's like saying, what's the
Oh.
difference between a rhinoceros
Yeah.
and a chicken? Well, one's grey and the other.
No, one of them says
isn't.
none in front of it. What does that mean?
My god, not what you
Yes,
think, obviously.
just like-
Wait, no, I'm
Just
sorry, one
like
sec.
Okay.
Rob's.
I literally have been working on the assumption that you were smarter than I thought. And I apologize for making that assumption, because what you've just said shows that you are so dumb that I need to take you down an extra
Gaslighting's
couple of
doing
levels.
really well here.
Okay.
Gaslighting's not
I
real.
wanna
You
ask
made
you
it
a
up
question,
because you're
Bev.
fucking crazy.
Bev, I want to ask you a question, a serious question. On a sphere, okay, what's the largest that we can make a triangle? And speaking of the summation of internal angles in non-Euclidean geometry on a sphere, what is the largest sum of the three internal angles that you can possibly have, and why?
Something like 270 degrees, something like that, is it? I don't know.
Nope.
That's just a guess.
Nope.
Go on, what do you think? You
Okay,
can
so
get?
if you were to take 3 points on the take 3 points on equidistant on the equator and draw a line between each one of them, that is essentially a triangle.
On the equator or on the sphere? What
540
are you talking
degrees.
about?
540
On the
degrees.
equator of a
Okay,
sphere.
that's what you can do. This is how they determine
Sorry?
things
Say
like
that again.
spherical excess. Say what again?
You can get a
So,
triangle
Imagine a
with
sphere.
540
Imagine a
Yes.
degrees. Did you say that?
Uh-huh.
Yes, a spherical
Yes,
triangle.
540
yes.
degrees, yes.
So imagine so you have a particular image of a triangle, and you need to just accept that a triangle is formed by 3 points on a surface. In this case, we're going to use a spherical surface. So imagine
Triangles, right?
yes, and
Just
there
quickly,
are three
question for the
angles.
chat. Brian's logic wants on. 1 for yes, 2 for no. Carry on.
One.
So the yes, and you're this is basic. This is
Geometry.
your yes. This is basic geometry. This is basic
It
geometry.
is. Yes, what an angle
And you're
is.
demonstrating you have no
there are
idea
three
what basic
angles,
geometry is, Bev.
Each of
Yeah.
which is 180 degrees. What's 3 times 180?
God, he doesn't
Sorry,
know
an
3
angle
times
of
1.
180 degrees.
Yes, we have
Yeah, do
three
you know what
angles
that
of
is?
180
That's a
degrees.
straight line, right?
Yes, except that in a
Hold on. Didn't you say on a spherical surface there is no straight lines? They're all bending. They're all curving.
Well,
So how are you
180
now
degrees is a
redefining?
straight
Why
line,
are you
right?
contradicting
I was just-
yourself
I was
right now?
just out-
Why are
I
you
was just having
contradicting
a
yourself
go.
right now?
Well,
Right.
he agreed.
Okay. Continue.
So, actually,
I was
you
pointing
will-
out your
you will
contradiction,
recall
Bev.
that-
I'm sorry, Tony. Go ahead.
You will recall
just
that I
laughing at
didn't
your
agree
angle.
with you. You will recall that I actually tried to correct your two-dimensional thinking about the way angles are defined, but apparently without success. So, yeah, you understand that the universe is four-dimensional, right?
What would they be?
At least four-dimensional.
Go on.
there'd be three
Which
spatial
would they be?
dimensions: time
I know length, breadth, and thickness. I know them three.
and time.
Time.
Yes.
Right. So are we
If
are
you're
we
trying-
living are we in 4-dimensional space? Brenda said the other day that Euclidean geometry doesn't apply where gravity's involved.
Bev,
What do you think of that?
Bev, Brenda isn't here, so we don't really worry about what Brenda was saying. Stick to the point.
Well, you
please.
worry
So
about
the-
what all the other people say, don't they? You put clips of them, don't you?
You're bringing up Brenda. Brenda isn't here. There's a PhD guy here answering your questions. Maybe try and learn.
Okay.
So the
So Bob's not here either, but didn't you play a clip of him earlier?
Oh yeah, but that's freely available.
Well,
As a
that's Bob, isn't it?
demonstration.
So he's not
So
here
the- so
to
the-
defend himself. So why'd you bring him up?
Because he made the observation and posted it on Netflix for us
Oh
to
well,
use.
Brenda said that. Well, I said the other day,
Yep,
right?
Yep.
Same thing.
Brenda hasn't done an experiment to demonstrate the Earth rotated. Has has that happened? No. Bob did.
Is this
and
what we
recorded
are
it.
doing? Is this
Bob,
Earth
Bob
rotation?
did. Bob
Sorry,
did,
I'm taking
and
you away from geometry.
Bob did and posted it on Netflix, so we get to use it.
Okay.
So anyway, back to the questions. Brian has the
Okay.
link to join, by the way.
So
just
the-
turn the dumpster fire up to 19.
So so three-dimensional reality has the potential to be more complicated than two-dimensional reality. Do you accept that?
2-dimensional reality? You mean a plane surface?
So yes. So
God.
so geometrical principles that work for a plane are not necessarily the case on generalized surfaces in 3 dimensions.
Well, surveyors use Euclidean geometry, right? In all measurements. Like you use Euclidean geometry whenever you're doing Pythagoras or trigonometry, right?
It's
Depends on the
interesting that you
situation.
should bring that up. It depends.
Well,
on the
right angle
situation a
triangles,
little bit,
that's
but
definitely Euclidean, right?
Yes, I would suggest that that's actually trigonometry. I would not call that Euclidean geometry. And
Based on a triangle of right angles and 180 degrees.
One
That's
sec, Bev.
definitely geometry, right?
Just want to introduce Brian, who has joined Brian's Logic. This is PhD Tony. He can teach you all about your questions. But let Bev finish his point, and then we get to you. Okay.
Hello.
Thanks for joining.
All right, Bray.
Hi.
All right, Bev, carry on with your point.
I don't know what the point was.
I would just when you say that trigonometry is a form of Euclidean geometry,
No,
I would
triangle
hesitate to sort of
is
make
geometry, right? The triangle.
yeah, but there's
shape.
different.
That's
but,
definitely
so,
geometry.
So if you what you describe as geometry and what I mean geometry are actually very different things.
Oh. Do you not
because
use Euclidean geometry?
I do, but I am not restricted to planar geometry. I can.
Euclidean
I have
has solid
the technical,
geometry, right?
Yes, Euclidean has solid geometry.
Yeah.
But if you have lines or curves on the surface of a non-flat solid, they don't obey the same geometrical relationships as they would if they were on a flat surface, right?
Yeah.
And I do want to point out that
balls,
listen,
Yeah.
Bev, when you start talking about internal angles of triangles, you're literally talking about trigonometry, not geometry. So yeah, I think you are absolutely getting the two conflated. It can be unintentional. I'm not saying you're doing that to be like dishonest or anything. I'm just saying I believe you're conflating geometry with trigonometry, whether it's intentional or unintentional. I don't know.
It's just a triangle, right? The trigonometry is based on the
It's just
functions of
trigonometry.
a
That's
triangle
fine.
and the
So-
sides and the angles, right?
Yep. That's right. But
Yeah.
so a triangle is just a triangle in a generalized surface is the shape produced by any 3 points placed on that surface. Okay. And there will be connected by geodesics on that surface. And so you measure the angles between the geodesics connecting those points.
Do you have a definition of an angle measured on a curved surface, right? Because I don't know.
God.
They're always straight
Yes.
lines, right? That's just the point I was making right at the very
They're
beginning.
Right,
geodesics. They're geodesics.
I do feel like
Yeah.
that conversation has
Yes.
gone round in circles, and it has been answered several times
Yeah,
already.
it should have been straight lines, though, shouldn't it?
The
Not
easiest
circles.
way.
That's the point.
No, the easiest way to understand it is that it is a continuous string. A geodesic is a continuous string of infinitely small straight lines. Okay, so when
Yep.
it's following a geodesic, it is literally a small set of continuously straight lines that are going around a curved surface. So at the
That's
point where you're
ridiculous,
measuring
dude.
the angle, you're No, it is not. It's fucking calculus.
is.
Okay, I can
Straight
understand how it's
lines that
fucking hard for
curve.
you to understand,
All
but
of
it's
you.
fucking calculus, so you need to
All
understand
three
that.
of you.
Okay, so
Bendy straight
it's not our
lines.
it's not our fault. It is
crazy.
not our fault that
Right.
you don't understand.
How
It's
do you
not our fault that you don't
differentiate
fucking
between
understand.
a straight line and a
Dude,
curved
it
line?
is not